actually write on that cheat sheet today, so try to take that out, because you'll write on it and that will help you on your next test. We only have 4 days this week and 2 days next week of the class left before the tri ends. And I did put up there kind of what the schedule is. So we're gonna learn all 4 days now. For the rest of the week, we learn a new section. So you're gonna actually learn a lot this week. There's a lot of different properties we learn rectangles today. I think this one, anyway, we end up learning rectangles, rhombi, squares, trapezoids, and kites. So 5 different things within 4 days. So today what we're gonna do is start off with rectangles. And first of all, everything that you know about a parallelogram, so like on this sheet, I know we haven't used it much yet, but we will now. These properties that were of a parallelogram are all properties for rectangles, rhombi, and square. So everything that we've learned about a parallelogram is true for a rectangle, a rhombus, and a square, okay? The things that are new about a rectangle is one thing you've probably learned since early elementary is that a rectangle has 4 right angles, okay? And then the opposite sides are parallel and congruent. We knew that already because of a parallelogram. Opposite sides are congruent was true about a parallelogram. Consecutive angles are supplementary, so that means like angle D plus angle C equals 180. That we already knew. And diagonals bisect each other. We knew that. Okay, so if we had a rectangle, or I'm sorry, a parallelogram, we knew that we had these 2 pieces equal and those 2 pieces equal. Okay, so that was for a parallelogram. Now, the 2 new properties that we're gonna use today is where the 4 angles are right angles and then the diagonals are congruent. So if you look down here, we have a theorem that talks about the diagonals of a rectangle, and this whole diagonal, JL, is congruent to this whole diagonal, MK, okay? And what happens because of that is that all 4 pieces of those diagonals bisect each other, okay? So that's something that's super important in a rectangle, is not only is the whole diagonal congruent to the other whole diagonal, but all 4 of these pieces are equal, okay? Now, on your cheat sheet that you guys have, for the rectangle, which is the second one down, so looking at your cheat sheet, do this on the rectangle. Are the diagonals drawn yet on the rectangle? No. So draw the diagonals, okay? Mark how all 4 of these are congruent. And then I'll just point this out to you guys. Do you see how 1, 2, 3, 4, those 4 are equal? The ones I have in green. And then notice that 1, 2, 3, 4, those 4 are also equal, okay? So draw your diagonals, show that these 4 pieces are equal, and then show that these 4 angles are equal, as well as these 4 angles are equal. And then right off the side, do this. Put diagonals are congruent. Okay? Just so you know that not only are those 4 pieces equal, but the entire diagonals are also congruent. Did I give you enough time for that? Okay, so now what the rest of this is going to be is just using those rules that we just went over. So if you look here, notice how they tell us measure of angle 1 is 37. Okay? Everybody look up here. If this is 37, that makes this 37, this 37, and that 37. Okay, everybody get that? Now, in a rectangle, each of these angles are right. Okay, so if this is 37, could I find angle 2 there? Wouldn't I go 90 minus 37? And 90 minus 37 is 53. Okay, so that is that one. So one of the things we learned today is that these that I'm putting in as 53s for the green are all equal. Okay, so notice my blue 37s, always those are going to be equal, and my green 53s, always those are going to be equal. Then, can anyone tell me how I could find angle 6? Yeah?
You take 180 and subtract 2 37s.
Yeah. So if you added 37 plus 37, which of course you don't have to show this, that's 74, and you subtract that from 180, that's 106, okay? And that would be what this is right here, okay? Then, would I be able to find angle 7 if these two form a line? Right? Don't they add up to 180 if they form a line? So if this is 106, this is 74. So let's just go down and write that in. So angle 2 is 53, angle 3 is 37, angle 4 is 37, angle 5 is 53, angle 6 is 106, angle 7 is 74. And so those are your answers. Okay. Now, let's go to this page. Okay. Now, this says BE, this little piece right here, is 6y plus 2. Then CE, which is this piece right here, is 4y plus 6. Do you guys remember writing on your rectangles that all 4 of those pieces are equal? So can't we just set those equal to each other? So we can say 6y plus 2 equals 4y plus 6. So I'm going to subtract 4y. 6y minus 4y is 2y plus 2 is 6. Subtract 2, and I'd get 2y is 4. Divide by 2, and y is 2. All right? Now, if we look down at B, it says the measure of angle BEA is 62 degrees. That's this angle right here, okay, like right here. And then it says find the measure of angle BAC right here. Now, this is something you may not know yet, because I haven't really spoke about this, but if you look at this triangle, one of the things we know is that all four of these pieces are equal. So each of these triangles are isosceles triangles. And do you guys remember that if you have an isosceles triangle, if these two are equal, doesn't that make this angle congruent to this angle? Do you guys remember that? So if this is x, that makes this x. Now, could I find those if I know one of the angles? Do you remember how we did that? Yep, you could go 180, very good, minus 62, and that gives you what the two angles add up to. And then if you take the 118 divided by 2, that would give you 59, and that's what each of those would be. If that is confusing for you and you don't like that, you also could have gone x plus 62 equals 180, because those three would all add up to 180. And then you'd get 2x plus 62 equals 180, and then you'd get 2x equals 118, and then divide by 2 and x would be 59. So either way works, whatever is easier for you. Now if we look at this one, it says measure of angle AED, which is right here, is 12x. And the measure of angle BEC, which is right here, is 10x plus 20. What do we know about those two angles? They're congruent because they are vertical, right? So I can say 10x plus 20 equals 12x. Then I'm going to subtract 10x. And I get that 20 is 2x. Divide by 2. And x is 10. Now one thing you have to be careful of is to look at what they want. And this one didn't just want x, they want the measure of angle AED, and AED is 12x. So then I would take this 10 and put it in here. So I'd go 12 times 10, which is 120. Okay. Now, if we look down here, it says BD is 8y minus 4. That's the whole diagonal, you guys. This whole diagonal is 8y minus 4. Then they tell us that AC is this whole diagonal. So this gives us 7y plus 3. So if we look back at that first page, we wrote here that the diagonals are congruent. That means the whole ones are. One other thing I might have you guys write on your cheat sheet, if you can, is that the 4 small triangles are isosceles. So what I mean by that is, like, this is one of the small ones. This is one of the small ones. This is one of the small ones, and that is one of the small ones. So those 4 are all isosceles, so keep that in mind too. Okay, so the diagonals are equal is what we wrote down. So that means those two pieces equal each other. So 7y plus 3 equals 8y minus 4. And then I'm going to bring my y over, And 3 is going to equal y minus 4. Then I'm going to add 4. And I get that y is 7. Now, one thing you have to be careful of in this lesson is to look at what they want. And in this one, they want us to find BD. And BD is this blue diagonal, which is 8y minus 4. So BD is 8y minus 4. And I would take that 7 and put it in here. So I'd have 8 times 7 minus 4, which is 56 minus 4, which is 52. So sometimes they don't just have you solve for x or y, you have to substitute it back in. So make sure you check on that. Okay, let's go to this page. And here it says the measure of angle DAC, which is right here. Okay, DAC is 2x plus 4. And BAC, which is right here, is 3x plus 1. Okay? What do we know about those two angles if this is a rectangle? They equal 90. Remember, in a rectangle, all 4 angles are right angles. So if you know those two pieces, you're just going to say 2x plus 4 plus 3x plus 1 equals 90. 2x plus 3x is 5x. 4 plus 1 is 5, and that equals 90. Then I'm going to subtract 5, and I get 5x equals 85. Divide by 5, and x is 17. And then what I have to do is find the measure of angle BAC. Okay, BAC is my angle in blue here. It's also listed here if you needed it. BAC is 3x plus 1. So I'm going to take that 17 and put it in there. So it'd be 3 times 17 plus 1, which would be 51 plus 1, which is 52. And that would be our answer. Okay. Now let's look at this one. It says the measure of angle ABD right here is 7x minus 31, and CDB right here is 4x plus 5. So I'm going to take you back to that first page. Do you guys remember how these in green are all equal? 1, 2, 3, 4, as well as those 4 in blue are equal. That's what we would use here, okay? Is that, don't forget, like I could even go back to that color. These 4 angles are always equal. So I could say 7x minus 31 equals 4x plus 5. And then you're going to go ahead and solve it. So you're going to subtract 4x and get 3x minus 31 is 5. Add 31 and you get 3x equals 36. Divide by 3 and x is 12, okay? But notice they want us to find the measure of angle ABD, okay? So the measure of angle ABD is right here, or right here. It's the 7x minus 31. So I'm going to take that 12 and put it here. So it's 7 times 12 minus 31, which is 84 minus 31, which is 53. Okay. Then, if we go to this page, it says quadrilateral RSTU is a rectangle. If RTU is 8x plus 4, RTU is this angle right here, and it's 8x plus 4, okay? Then it says SUR, which is this angle right here, is 3x minus 2. Yep.
Isn't the SUR the same as like STR, which would equal 90?
Yes.
So you just add them up to equal 90?
Yes. This angle is equal to all of these angles. Okay? This angle is equal to all of these. So that means this is 3x minus 2. And then this is a right angle because it is a rectangle. So we could go 3x minus 2 plus 8x plus 4. So 3x minus 2 plus 8x plus 4 equals 90. And then what we would do, 3x plus 8x is 11x. Negative 2 plus 4 is 2, and that equals 90. Subtract 2, and 11x equals 88. Divide by 11, and x is 8. But again, they don't always just ask us to stop there. And this time we want the measure of angle SUR. Okay, SUR. Oh, no, I'm lying. They want x. So that is what they wanted. So we could stop there. So that was our answer down here, x equals 8. Okay, if we look at this one right here, they say angle DAE, which is this angle right here, is 70. Okay, find each measure, and one of them they're asking us for is CEB right here, like right there. Okay. These are the diagonals. What do we know?
That like this angle 70 would be the same on the other side. And then if you do 180 minus...
Like these two?
Yeah.
Is that what you mean?
Minus 140, it would be 40.
40?
Yeah.
Yeah. So here, these four are equal. That's true. And we're looking for that one. That's our x. Okay, so we can do 70 plus 70 on a calculator or in your head, and then 180 minus 140 is 40. Okay, that is this angle right here that we just found. So that goes right here. Then they ask us, what is angle EDC right here? EDC. Yep.
You just take 90 minus 70 because it would be the same as the top triangle.
Yes.
So
These are a right angle, right?
Yeah.
So the 70 and the x add up to 90. So this would be 20, as well as this would be 20, this would be 20, and this would be 20. Okay? So this one is just 20. All right, in this one, it says angle ZXW, which is right here, is x minus 11. And WZX, which is right here, is x minus 9. Anyone see how we could do this one?
They equal 90.
Yeah.
So you add those two for 90?
So did you move one of them?
Yeah.
Which one did you move?
The x minus 11.
Okay. And did you move that right here?
Yeah.
Okay. Remember, if this is x minus 11, that makes this one x minus 11, that makes this one x minus 11, as well as that one. And now we have two angles that form a right angle. So we can say x minus 1, or I'm sorry, x minus 11 plus x minus 9 equals 90. X plus x is 2x, negative 11 minus 9 is negative 20, and that equals 90. Then we add 20, and 2x equals 110. Divide by 2, and x is 55. Okay, now, what we're gonna do next, they want us to find ZXY. ZXY is right here. Okay, so this is what I want to find, is that angle right there. So could I find this angle right here if I know that my x is 55? 55 minus 11 is 44. So that means this angle is 44. And remember, this is a right angle. So if that's 44, the one I'm looking for would be 90 minus 44, which is what, 46, right? And that would be the measure of angle ZXY. Okay, now we go to the last page. I know this is long, but we're almost done. All right. So the last thing that we're going to do is we're going to use Pythagorean theorem so that we can solve for a missing side in a right triangle. And I think we did talk about this a couple of times so far this year, but this works only in a right triangle. And one of the things we talked about is that in a right triangle, the two sides that kind of border that right angle are called legs. And then the side across from your right angle is called the hypotenuse. And what happened with Pythagorean theorem is that they realized that if you take one of the legs squared plus the other leg squared, it equals the hypotenuse squared, okay? So where you put A, B, and C, the C is the one that matters. C has to be across from the right angle, and that's your hypotenuse. A and B don't matter, so you can put them with either of the legs, okay? So if I come down here, they tell us that we have a rectangle, and it says XW is 6. WZ here is 8, and XZ right here is B, okay? So really what we're looking at here is this right triangle, okay? When I do that, and that's a B if you can't read that, when I do this, which one is my C?
B.
Yeah, kind of confusing, but what we're looking for is actually our C, that's our hypotenuse. The other two sides are my A and my B, okay? And then what I have to do is use Pythagorean theorem, a squared plus b squared equals c squared, so that I can find that missing side, okay? A and b don't matter, I just put the a with the 6, so this is 6 squared. B I put with the 8, so that's 8 squared. And this is kind of confusing, but the way they did it is c is actually b, so b squared, okay? Now, 6 squared is 36, 8 squared is 64, and then you can add those together, which you could have just done 6 squared plus 8 squared if you wanted to. Now, what do we do in math when we get a squared?
You have to
Square root, very good. So if I take the square root here, the square root of 100 is 10. Do you guys all know where to find the square root button on your calculators? Everybody, even on a graphing one? Okay. Now, let's look back to what they wanted. They wanted YW. YW is actually this diagonal. Right now, what we found is that this diagonal right here is 10. What did we say about the diagonals of rectangles? They're congruent. So if this is 10, what's this? 10. So YW is 10 is our answer. So there's a bunch of rules that you have to just keep in mind, but like you have that cheat sheet that you can use that has them on there. One more and then we'll be done. So XZ is this right here, and that is 3C. Then ZY is this, and that is 9. I'm actually gonna write that 3C on the other side. And then XY, they're telling me is 12, okay? Now, because this is a rectangle, this is my right angle, okay? And I'm gonna put in there, what is my A, what is my B, what is my C? Where is my C?
3C.
Yep, this is my C, that's my hypotenuse. Does it matter where you put A and B? No. So I can put A here and B here, okay? So if I write down A squared plus B squared equals C squared, we put 12 in for A and I have to square that. We put 9 in for B and I have to square that. And then C is actually 3C squared, okay? 12 squared is 144. 9 squared is 81. Now think about this. If you're squaring this, we have to square the 3 as well as the C. What's 3 squared? 9. And then I also have to square that C, so that would be C squared. And then I'm just gonna solve that. 144 plus 81 is actually 225. What would I do next? First, I would divide by 9 to get rid of that 9, okay? And then C squared would equal, is that 25, I believe? And then what would I do? Square root. And the square root of 25 is 5, right? And then when you look, you always have to look at what did they want? And they want YW, and WY is this. So does anyone know how we could find that?
3 and then input our C, because it would be congruent to 3C.
Yes, wouldn't the diagonals equal each other? So if one is 3C, the other one is 3C, okay? And I know C is 5, so what is WY? 15? right? Everybody understand that? All right, sorry it was long today. So here is your assignment. And then I'll work on your tests today. I can't promise I'll get them to you by tomorrow, but by the following day. So by Thursday, I'll have them done, okay?